All right, last class we developed the terminology of what statements are in logic. Today we're going to talk about negating these statements, and we're going to begin talking about truth tables. The negation of a statement is a statement with the opposite truth value. So negation sort of means opposite. Now some of these are pretty easy to do. For example, if I were to say the statement, "My name is Bob," if I wanted to negate the statement, I would simply say, "My name is not Bob." However, when we have quantifiers, sometimes negating these phrases are not as easy. For instance, if I were to say, "Everyone loves Raymond," it is not correct to say that the negation is "no one loves Raymond." The negation of "everyone loves Raymond" is there is someone who doesn't love Raymond. Another example is if I were to say "no one eats spinach," if I wanted to change the truth value, meaning if this were a true statement, that means no one eats spinach, all I would need is one person that eats spinach to make the statement false. I don't need everyone to eat spinach, I just need one. So, the negation of "nobody eats spinach" is someone eats spinach, or there exists someone who eats spinach. We talked about compound statements last class. Now what we're going to do is we're going to turn statements into symbols as well as the symbols for and or. We generally denote statements by letters P, Q, and R. For us, we won't be dealing with more than 3 statements at a time. But if we did, we could add in more letters such as S, T, whatever you would like. Now the symbols are the following. The word "and" is denoted by an upside down V, and the word "or" is denoted by a V symbol. We also have a symbol for "not." Again, we use the "not" for negations, and the symbol for "not" is a little tilde symbol, a little squiggle line. Alright, so let's put these into practice. I have 2 phrases. P is going to be the phrase "I like apples," and Q will be the phrase "I like cats." If I wanted to write down the phrase "I like apples and I like cats," well, I have P representing the phrase "I like apples," we have the upside down V symbol for and then Q represents "I like cats." Now let's say I wanted to look at the phrase, the compound statement, if you will, "I like apples" or "I like cats." Again, I use P and Q to represent each of those statements, and I use the "or" symbol, the V, to represent "or." Now, let's say I wanted to symbolize the phrase "I don't like apples." Well, "I like apples" is denoted by P, and with the tilde sign, that little squiggle, that means not. So literally, the tilde P is not "I like apples," but to understand that in terms of English, we say "I don't like apples." Alright, let's do another problem. We're going to have P be "I teach math," and Q, "I am a boy." What we're going to do is we're going to evaluate the truth of this compound sentence. "I teach math" is a true statement, but "I am not a boy," so "I am a boy" is a false statement. Overall, if I were to say "I teach math" or "I am a boy," this is a true statement because "I teach math" is true. This is different than if I were to say "I teach math and I am a boy." If I were to tell you that phrase, I would be lying to you. So we want to associate false statements with lies. Alright. So I have the statement "I teach math." the negation of that is I don't teach math. So that would be false. Now I could look at I teach math and I live in Pennsylvania. Both of these are true. So if I were to say I teach math and I live in Pennsylvania, this is a true statement. What we're seeing here is we're combining different statements, single statements with a single truth value, and we're seeing that the compound statement will have a truth value that depends on the individual pieces. For instance, I teach math and I live in PA are both true, but on the last slide we saw I teach math and I am a boy was false. Alright, that concludes today's lecture. What we'll do next time is we will put these into truth tables and figure out a way to symbolize these even further.